everyone, June the 8th. It's getting hot. It is getting hot. And, well, I cleaned my fan. I have two table fans. I cleaned both of them. I can't explain very well why, but when a fan gets dirty, the airflow just significantly reduced. And, I mean, I don't see why. I mean, there is dust and then hair and whatever it's in there, so I can see how it might affect airflow, but overall I don't see like too much of them. So I can say just like even with a little bit of the hair and stuff, it will cause a major issue. But anyway, so I clean it and then now I have it on, and then yeah, I think it's gonna help tremendously. Thank goodness where I live now is dry, so fan, when a place is dry, fan can help a lot in terms of getting it cooler. Yeah, the tough part is when it gets humid, so we got lucky. Alright, anyway, let's do this. Maybe a hard one? Yep, that's how I expected. Case smallest in lexicographical order. Two integers, return the case lexicographically smallest integer in the range from 1 to n, and k can be gigantic. Yeah, I think I remember I do this before. I think this is one of the I put in good interview question. I don't remember how this one is solved. Case smallest. Case smallest. Don't we have something similar? I think. Yup. There we go. There we go. Yeah, I remember this one. I think this is the one I didn't solve, right? Yeah, we're coming back. A full circle. I don't think I solved it. It's is that a copy and paste? Yeah, it's a copy and paste. It's a copy and paste, so I never really solved it last time. Well, let's not waste time, because last time we didn't solve it, we probably cannot solve it this time. And we definitely tried. Right? We tried. Dear me, we tried hard, but then it still doesn't work. You want to try it again? Just give it a thought. I don't know. I don't have any thought on this. Well, definitely we cannot count to the case, right? Can we ask another question? Give you a number. Do you know what is its order? Actually, no. I don't know. Then why do you put this as interview? This is not interview. This is a nightmare. Dude, this is a nightmare. Come on. We didn't solve it last time. So n is given, right? You have n. So you know the largest number. So yesterday's problem helps you find, to produce this sequence, right? Yesterday's problem helped you produce this sequence. You can definitely just keep producing a sequence, but then you're going to time out, right? So we're not going to do that. But you know the biggest number. So you know how much it's gonna go until it hits the big one, right? And then it's going to go, so it'll go like this, right? So you have 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, and then you're gonna go 1 all the way to 9, right? And then you have 1, 0, 1, right? Because you're plus 10, so you go 1, 0, 1. So you have, yeah, because you have 1,000, you definitely have 1, 0, 1. And then you have, you need to try 1, 0, 1, 0, right? And 1, 0, 1, 1, 1, 0, 1, 2, 1, 0, 1, 9. Or until you hit, you cannot go anymore. It's like regular counting, but right? And then you have 1, 0, 2, then 1, 0, 2, 0, right? All the way to 1, 0, 2, 9. Then you have 1, 0, 3. It's like between 1, 0, 2 and 1, 0, 3, you have to handle another bunch, right? And between 1, 0, 0, between 1, 0, 0 and 1, 0, 1, you have this bunch. And then between 1, 0, and then all the way to 1, 1, you have this bunch. Do you know the total number of this? So if we want to find between 1, 0 and 11, we need to find between 1, 0, 0, if it's possible to have 1, 0, 0, right? All the way to, what's the last one here? It's 109, right? 109. And then go 110, right? So it's 109. So 100 to 109. Right? And to find out that, I need to find between 100 to 101, how many is in between. And to do that, I need to find out between 1000 and then 1009. Now between this, how many is, right? So it's kind of a little bit of recursion here. Like how many is it between these two? And then if we keep thinking about the same, so we want to find this, we need to find between 10000 and 10001, right? And then to find out between these two, we need to go 100000 to 100009. So we're going to keep drilling it down until a point hits when we hit the limit. Right, when we hit the limit. And then we'll count the number for that. So we're not like have that many in between, that many in between, that many in between. And eventually we will have, so between this and this, right, so between these two we have that many numbers between. And is that larger than k? If it's smaller than k, then we move on, keep going, right? Keep going. And we just do like say 1 to 1 and between 1 and 2. How many between 1 and 2, right? and we find that out, we know it's that many. And then we say, is it larger than k? If it's smaller than k, then we say, okay, what's between 2 and 3? Right? 2 and 3. And we find out that it's, bigger than k, bigger than the remaining. Alright, so if it's bigger than the remaining, then we cut it in half. So right, so because 2, let's say between 2 and 3, we have something in the middle, which is, because 2 to 3 we'll need to do 2, 0 to 2, 9, right? 2, 0 to 2, 9. Because it would be 2, 0, it would be 2, 9. So in the middle it would be 2, 5. So we say, okay, let's try 2, 0 and 2, 5. How many is in between? If it's enough, then we keep splitting into half. So between 2, 0 and 2, 5, that's essentially we need to find 2, 0, 0 to 2, 4, 9. Right? 2, 0, 0, 2, 4, 9. So we find something in between. So 0, 0 and 2, 4, 9. We have to find something in between. That is going to be 2, 2, 5, right? 2, 2, 5. So yeah, so now we say between this, we say okay, now we can try finding between these two, so it's bigger. So now we need to find between 2, 2, 5 and 2, 4, 9. That's going to be 2, 2, 5, 0, all the way to 2, 4, 9. How do we get there? So it's 2, 4, 9, 0 minus 1. So 8, 9. And we just keep doing this. Keep doing this. Maybe it'll work, but I'm not gonna waste time. Let's just read. This is tough. Oh Lord. Yep. So we're repeating. It was the same sequence, huh? Alright, let's just, last time we didn't really handle it. That was from September 2024. We went in full circle. Alright, we need to find the kth smallest number. But hold on, so before we go into there, we have some idea. Would it work? Maybe. Maybe not. I don't know. But I'm not going to wait and find out. So let's just let it clear that, right? We'll make sure that this is for the record. Alright, we need to find the kth smallest number in lexicographical order. Hold on, I need water to lubricate my brain. And actually this is good. Like the problem that you copy and paste, that's fine because you're gonna do that again. And I'm telling you, a problem like this is just hard. At first, this might seem like a simple sorting problem. We could list all the numbers, sort them in lexicographical order, and pick the kth number. However, for a large value of n, this becomes impractical due to the sheer size of the list we need to create that is correct. Instead of generating and sorting all the numbers, we can treat numbers as trees, where each node represents a number and its children represent numbers with the same prefix. Structuring numbers this way allows us to find the kth smallest more efficiently. For example, the number 1 has children 1, 0 all the way to 1, 9. Similarly, 2 has children 2, 0 to 2, 9, and so on for other numbers. This gives us a prefix tree-like structure where each node corresponds to a number and branches out to other numbers by appending digits. If we traverse the tree in lexicographical order, it's as if we are listing all numbers in their proper order. Yes. So are you going to traverse everything? So it's like pre-order, like so 1, 1, 10, 1, and then you'll go back to get this. So we know the left and right, know the left and right. So this you can give the order, but you still need to know the total size so you can skip, right? Otherwise you have to traverse every single one. We begin by select the smallest lexical, which is 1. Kind of 1 is first, we subtract 1 from k. Next we calculate how many numbers exist in the subtree. Exactly, this is what we need. How many numbers exist in the subtree rooted at the current? By defining a helper function, count steps, which counts the numbers between two prefixes. Oh, this is actually very similar to how I was thinking, right? Two numbers between two prefixes, current and the current plus 1. It calculates numbers at each level, expanding the prefix as we go deeper. We know the case number is not in the subtree if the number of steps under current is smaller than or equal to k. Under these circumstances, we skip the next sibling. Under this circumstance, we skip the next sibling. Why do we skip the next sibling? And subtract the number of steps from k because we've skipped those numbers. It just says, like, we want to find between 1 and 2, right? So basically find all the count here. And if it's good, then we can skip all this and then move on to here. But I'm not sure. Like, on the other hand, if the number of steps is larger than k, we know kth number is in the subtree rooted at current. In that case, we move down one level by multiplying current by 10, effectively moving to the next digit in the lexicographical tree. We also decrease k by 1 because we've taken one step deeper into the tree. We repeat this process until k becomes 0, at which point we've found the kth number and we return current. Okay, I think I got the general idea. Let's see. Find kth. Oh, I put into a private count steps. I think this is the most important part. K larger than 0. Step. It's between current and a current plus 1, right? If step's smaller than this, we move on. K minus this, and then we find the next. Yes. Otherwise, we move deeper. Current times 10. Current times 10, yeah, whatever you do, wherever you are, and the next, your children is always going to be times 10. So it'll be current times 10, and then we try it again. And eventually we will get the current. Okay, I got this part. How do you count steps? So we have a prefix, we have another prefix. The two are different by 1, right? Well, prefix smaller equal to n. Steps plus equal to minus prefix 1. What? Okay, this I do not understand. So prefix 1 and prefix 2, want to find how many is in between, right? How many is in between? So like how many is between, let's say 1 and 2, right? So we'll do is 2 minus 1 is 1. 1 is 1. Oh, you don't count the next one. You don't count the next one. In between, including prefix 1. To do, but let's say n minus 1, n plus 1 minus this. And prefix times 10, prefix 2 times 10. Okay, count steps. I need to revisit the count steps. Add number of integers between prefix 1 and prefix 2. Move on to the next level. Oh, now I think I understand. I want to count between 1 and 2. Hold on, let me think of it. What do you mean by between 1 and 2? It's not between 1 and 2. It's everything under the subtree, right? Everything under the subtree. So you do 2 minus 1, so we have this, right? We have 1. And then times 10. 2 times 10 is this thing. And then you find, so 20 minus 10, this is 10. So we have 10. Holy crap. And then you keep times 10, keep times 10. So you find a number on a level. And then you get a total number on this subtree. Right? You get a total number on the subtree. But that is including the root. Right? That's including the root. So why do k minus minus at the beginning? This will count everything under the subtree, including current. Right? Including current. I feel we're double counting. Seriously. I feel we're double counting. Number of steps. I think that's the key. The steps. I mean, the step is this. This is 1. Right? And then this is another one. And then we have 1. Hold on. Number of steps. I use step to do this. Hold on. Let me just do one more thing. So we have 1 0, 1 1, 1 2, all the way to 1 9. Right? So 1 2. This is 1 2 3. This is a 9. Right? This is a 9. But this is the first one. This is the second one, right? So this is 1 2 3 4 all the way. This is a 10. The 10th one is 19. Is that right? Yeah. Therefore, when you say between 1 and 2 is 1, like if k is equal to 1, oh, if k is equal to 2, right? If k is equal to 2, then it will be 1. And then this level is going to be 20 minus 10. It's going to be 10. We have 10 numbers here. Right? I have 10 numbers here. 10 numbers. So we're starting from the 2. Right? 10 numbers. We're starting from 2. And it's too much. is the count based on this, right? Count based on this. So I'll say count between 1 and 2. I say count between 1 and 2. This is going to give me 2 minus 1 plus 20 minus 10. This is going to give me 11, which is 11, right? And then k is equal to k is equal to 2, right? K is equal to 2. So I say I will count k is equal to 2, and then n is equal to 13. N is equal to 13. N is equal to 13, and then that basically is plus 13, 14, right? So it's 4. And then we go to 5. We go to 5. And then when we get a 5, it's already too big, right? Because here we say it's already too big, right? It's too big. Then we'll return 5. Okay? So return 5. So the steps is 5. 5 is larger than 2, right? So I'll move down. So now it become 10. Right? Now it become 10. And each time I move down, I'll minus 1. So move down minus 1, this one I understand. Right, move. Alright, come in. Yes. Estudiantes. Alright, I'm back. Still need more understanding, right? So we count this, we get the 5, so it's too much. So we move down. And when we move down, we need minus 1 because we cannot count this. So now we don't count 1. So now we need to find from 10 to 11. How many is 10 to 11? So 10 to 11 we can count, which is 11 minus 10 plus which will be 110 minus 100, right? 110 minus 100. Right, however, it's not 110, it's 13. Okay, that's the maximum. Minus prefix 1. Wait, how'd you get there? I find between 10 and 11. Oh, prefix smaller than. Ah, yes. So we don't even do this. So this is giving me 1. Right? Between 10 and 11. It's just 1? Oh yeah, because I don't have another thing. So it's just 1, right? You just give me 1. So step from this to this is just 1. And because I have 1 already. So I add. So step is 1. Right? And then these are the same. Right? These are the same. They're the same. Current plus plus, so current goes to 11. And then we get out. And then you return current. That's wrong, because it should be 10, not 11. Let me think again. I mean, what this means is we count this, and then we say from 10 to 11, there are 1, right? There are 1, or like there are a lot. So if there are not a lot, then we can do minus minus. Right, we'll do minus minus. And then minus step. And then let's move on, right? So k, because it can also happen. That's k minus minus. But if k minus minus, because you move down, then you should return current. But if k minus step, can't wrap my head around this. Because current is 1, and then you will copy stuff from current to current plus 1. You copy stuff from 1 to 2. Because 1 already counted. Right? That's the confusion. 1 is already counted. And then 1 to 2 give you 5. Right? They give you 5. It's basically 1, 10, 1, 10, 11, 12, 13. You have 5, right? 13. Right? Is that 13? Yeah, 13. Yeah, you have 5. And then we say the total amount is too much, right? So we need to move it down. And move it down, k minus 1. So now we have 1, right? So now we need to find from 10 to 11. How many are from 10 to 11? Now we find out from 10 to 11 there's only 1, right? There's only 1. And then step, and then becomes 0, right? Becomes 0. So when it becomes 0, it should be the current. So we don't do current plus plus. But when do we do current plus plus? If it's still larger than 0, then we do current plus plus. But I don't understand why you just minus this one first and then everything will work. It's like magical. Yeah, I think I'll do it differently. It may make more sense to me. Like, I don't know why this one will work. Like, we decrement this, and then we decrement steps again. It's like we count this one twice. But it freaking works. Alright, anyway. Let me try my idea and see if it works. I failed this problem in September 2024. I promised myself to revisit it, but I have not done so until this problem pops up again on the daily challenge. Now I read the editorial and understand the method, right? Basically, we want to find all the numbers between current and current plus 1, right? Current plus 1 with current inclusive but current plus 1 not. This can be done by thinking about the layout of the numbers. Numbers as a prefix tree, right? Where current is the root and all its children are current times 10, current times 10 plus 1, right? Current times 10 plus 1, current times 10 plus 2, current times 10 plus 9. Right? And to find the number, the count of numbers between current and current plus 1, we count the level. Yeah, we count the numbers on the level, then move on to the next level, and so on until until a level, until the beginning of a level is larger than n, right? Once the count is available, we will know whether the case number is within the subtree, within the tree, rooted at current or not. If not, we move on to the next subtree, to the next subtree. Otherwise, we drill down. We'll drill down current by multiplying it by 10. Something like that, right? So what we're going to do is we're going to do a function called int count, right? So we have n, yeah, we do long. Do we always count between current and current plus 1, right? We always count that. Not necessarily. Well, I mean, left and low and high. Okay. So we'll count between this. So we say int rest equal to 0. So while low is smaller equal to n, rest of plus equal to high minus low. Actually no, we say td minimum n plus 1 high minus low, right? Rest plus equal to that. And then low times equal to 10, high times equal to 10. Then we move on to the next level. And return rest. And do a long. Okay, that's count, right? And then we'll say int current is equal to 1, right? And we say while k is larger than 0, right? K is larger than 0. Then we say int count and current plus 1. Right? That's the count. And what do? We say if count is smaller equal to k, right? Count is smaller equal to k, then we say k minus equal to count. If k is equal to 0, we'll break. Otherwise, k is not equal to 0, then current plus plus. We move on to the next current. Else, is count is too large, and then we immediately move on to the next one. We say k minus and current times equal to 10. Right? Move to the drill down, right? Drill down to the next level. And I will return rest. No, return current. Yeah, not sure, but we'll give this a shot. It's different from this. say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to find this. That's as random as I can get. That's as random as yeah, yeah. So this makes more sense to me. Right? This makes more sense to me. You remove it, and if it's 0, that's the current, right? The current one. If not, you have to move on. Otherwise, we draw to the next level. So let's try it. Ugh. Ugh. Oh, the edge cases. Oh, the edge cases. Jeez. Output 90. Expected 9. Ugh. Can we have a simpler case? Damn it. How about this? Would it work? Probably this one does. Damn it. 100. K is equal to 90. I feel like we did time is equal to 10. I feel like current is 9, right? And then we do something and we find out. Let me think again. So current is this, but I'm not doing the minus minus first. I find out between current and the next how many there are, right? In its subtree. This is the same. This helper function is the same, so I don't think there's anything special here. This I do exactly the same. Yeah, the helper is the same. Just the difference is in here. I decide to not do the minus minus at the beginning because we are not drilling down. Like, why do we do minus minus at the beginning? We're not drilling down. So I say, okay, I'll take this, right? I say if I remove this, I want to count, right? And I do the count, and we find out that the count is whatever number. So we minus that. Because between this and this we have that number. Like say we have 5, right? So we remove those 5, then move on to the next one. Right, move on to the next one. And then we try it again. And let's say now the count is too big. Right, so from this to this, count is too big. So I move one lower. Man, I don't know. Alright, I don't know. It just feels. Okay, how about we do this? I don't know. I want to find some 9. I don't know, 19, 29, 90. So maybe, hold on. Maybe we'll do like 10, 20, 30, 40, 50, 60, 70, 80. Oh, you gotta be kidding me, man. put it 8. You know what? I don't believe it. So we want to find 0 is 1, so 89 is actually 88. Yeah, it is. Fuck me. So 1 and 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So I have 12 between 1 and 2. So I have 12 between 1 and 2. Between 1 and 2. So this is a 1, and then between 10 and 20. This is a 10. And then between 100 and 200. And then this is 100 and a 1, so it's 1. Yeah, 12, right? So 12. And we're looking for 90. So we're going to move on. So 90 minus 12 equal to 78. Right? So we have 78 left, and then current going to be 2. So we do 2 to 3. 2 to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11, right? Which is true because we don't have this, right? Because when we come here, it's too big and it's not going to count. So yeah, 11. So in minus 11, we have 67. Okay, so now we go to 3. 3 to 4, that should be 11 as well. Alright, 3 to 4 is 11, so we have 56. 4 to 5 is 11. So now we have 45 left. Right, start with 5. And then 5 to 6, we have 34 left. And then we start with 6. 6 to 7, we have 23 left. Now we start with 8. Now we start with 7. 7 to 8. And that's 11 as well. So we have 12 left. Now we start with 8. Alright. Start with 8. We have 12 left. So now we do 8 to 9. 8 to 9. 8 to 9 should be the same as 11, right? 8 to 9, where's 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? We have 11. 8 to 9. We have 11. So we minus 11. So we have 1 left. Now I'm going to start with 9. Right? We start with 9. We have 1 left. So k is equal to 1. Count is going to be 9 to 10. Oh, is between 9 to 10. That is not right. Count is 9 to 10. Count is 9 to 10. I cannot do. They have to be the same digit, same number of digits. So if they have different number of digits, that's where the problem is. If they have different number of digits, okay. What do I do if they have different number of digits? Then, because 10 is not on the same level, right? 10 is not on the same level. So what we need to do is, like, if 10 is here, then we have 100. So it's fine. It's just we cannot do this. This we cannot do. Then we have to check if they're on the same level. How do I check if they're on the same level? If it's equal to 9, right? If it's equal to 9, then we know we cannot do this. So basically we don't do this first step. This step we don't do, right? This step we don't do. So like if low is equal to, if low ends with 9, right? If low ends with 9, then we immediately just do the next one times 10. So it would be 90 to 100. So that gives us 10, right? That gives us 10, which is true. But you still have to count 9, right? Yeah, you still have to count 9. So I count 9. I count 9. No, it's fine. It's fine. We count 9. And when we count 9, 9 is smaller or equal to 100, right? And then we go to 90 and then 100. Right, now we become 11. Right, this is still 11. I have 90 to 99 and a 9. That's still 11. So we still return 11, right? We still return 11. So the count is 11, and then k is equal to 1. So 11 is smaller than k? No. So we do this, and then count times equal to 10. Okay, I think what we need to do is, because we drill it down, so we do this, we have to check if k is equal to 0, then we will need to break. Still not right. How? Current is equal to 9. Yep, this one's right, but this one's wrong. Oh, Lord. 89. That's 89, which means everybody is going to be so just like minus 1, right? Minus 1, so this is like 22, this is going to be 11, right? This is going to be 11, right? 8 to 9, 11, and then 8 to 9, when we find out is they have 11, right? They have 11. They have 11. 11 and they have 11. I need to find out what that 11th is, right? So they have 11 and then it's equal to k. So maybe I turn this into a smaller than k, not smaller, equal to k. I turn it has to be smaller in order to move on, because if it's equal to, we don't really move on, right? If it's equal to, we don't move on. It's equal to, we have to drill. If it's equal to, we have to drill. All right, so let's reset the test case. And then, yeah, 90. Yeah, if it's equal to, we don't drill down, right? Because equal to, if equal to, we need to drill down. If it's not equal to, then we can go to the next one. Okay, let's try this. There we go. Now this makes more sense to me compared to what the editorial is saying, right? This makes more sense to me. But of course, like if we can handle it more, it's like you do this minus and you check, you do this minus and you check, right? So I think what the editorial does is it pre-minus 1, right? It just take 1 away initially and then you do everything. So you will hit these points before. But yeah, I don't know. I don't know about it. I like this way, and then I'm sticking to it. All right, that'll be it. It's worth it. That's a good hour spent. I'll see you guys tomorrow. Adios.